Hi, Assalamualaikum and good morning to our lecturer. We are from Group 4 and we would like to present our group project for numerical method. But firstly, I would like to introduce our group members, which is Balqis Farzana, Jemima Faith, Meryl Shasha, Siti Nordiana, and also me myself, Siti Aishah.
Here are the contents for this video, which is firstly we have introduction, and then we'll see real world application of eigenvalues and eigenvectors, method of assessment, result and calculation, discussion, and lastly the conclusion. So continue with the introduction.
Hi and Assalamualaikum. My name is Balqis Farzana. Binti Azman Shah. My matrix number 80 2021. Today I would like to talk about the introduction and objective. For the eigenvalue are a subset of scalar that associate with the system of linear equations. It is more commonly found in metric equation. Eigen is a German word that means proper or distinctive. As a result, the term eigenvalue can also be referred to as a characteristic value, characteristic roots, proper values, or Latin roots. In layman's term, the eigenvalue is a scalar used to transform the eigenvector. Eigenvectors are non-zero vector that do not change direction from a linear transformation is applied. It's only changed by a scalar factor. In summary, is if A is a linear transformation from a vector space V and S is a non-zero vector in V, then V is an eigenvector of A if AX is a scalar multiply of X. For the objective, we are going to find the eigenvalues and corresponding eigenvector of the mechanical system using appropriate numerical methods. To apply appropriate numerical method using mathematical software in assignment and project, and to independently proceed engage lifelong learning in a guide assignment.
Okay, these are the real-world application of the eigenvalue and eigenvectors. Firstly, population growth. Matrices can be used to form models for population growth. The first step in this process is to group the population into age classes of equal duration. For instance, if the maximum lifespan of a member is years, then the following intervals represent the age classes. Okay, over a period of L over n years, the probability that a member of the N age class will survive to become a member of the L plus 1 age class is given by Pi. Then the average number of the offspring produced by a member of the N age class is given by Bi. These numbers can be written in matrix form. Multiplying this age transition matrix by the age distribution vector for a specific time period produce the age distribution for the next time. Okay, the second real-world application is the mass spring model. The mass spring model, one of the basic concepts of vibration, use eigenvalues of the two dimension of freedom system where two equal masses attached to walls by equal springs and also to each other by spring can be expressed as those equations. Okay, here are the M, C, and K is referred respectively as the mass, damping, and stiffness matrices. When there is a free vibration, which means no damping and no applied forces, the equation become like those equation. Okay, assuming the exponential solution of type x e power of iwt, reduced equation reduce dose equation is referred as eigenvalue problem. Pre-multiply the equation by m power of -1, put m power of -1 and it becomes k is equals to a and omega squared is equals to lambda. The equation becomes like that. The frequencies of the oscillation are provided by eigenvalues uh, of the equations, whereas eigenvectors represent a pattern of motion of the system. Eigenvalue and eigenvector defines free vibration mode of the structure. The J eigenvalue refers to J frequency, where frequency is equals to omega over 2 pi. Okay, last but not least, the real-world application is electrical engineering. Electrical networks can be expressed as weight graphs with vertices, undirected edges, and a set of conductivities along each of edge. Boundary nodes hold voltage F, and interior vertices hold current P, phi. A map from F to phi is known as response map. A network having a wide range of vertices, it is not possible to estimate the current flow through network. Eigenvalues are voltage for which network behave in predictable way. Eigenvalues give information of current flow, whereas eigenvectors are the values of the boundary voltage, for which boundary voltage is scalar multiple of boundary current. Okay, the Kirchhoff matrix gives the relationship of parameters to be considered defined as those Kij, where Yij represents conductivities between vertices Vi and also Vj on graph. Kirchhoff matrix like A, B, Bt, and C is constructed, which is transformed to response matrix using A minus Bc power of -1 Bt, and eigenvalues of matrix gives information of stable or unstable load of network. And that's all for the real world application for eigenvalue and eigenvectors.
Hello, my name is Jemima James. My metric number is CD 2016. So today I will present about method of assessment. The method of this report, we choose to utilize the eigenvalue and eigenvector using characteristic equation as one of the methods to answer our problem in order to determine the vibrating system with two mass and two springs. We are using all the formula for this strategy is the fundamental approach to solving this problem. So from the Hooke law, F equal to Kx, this is the equation that we use. And from the Newton's second law, F equal to ma, this is the Newton's second law we are using. So combine both the equation equal to m1 x1 plus k1 plus k2 multiplied with s1 minus with k2 multiplied with x2 equals 0. And then m2 x2 plus k2 x2 minus x1 equal to 0. Then substitute back equals to negative m1 omega square v1 sine omega t plus k1 plus k2 multiplied with V1 sine omega t minus with K2 V2 sine omega t equal to 0. Then negative M2 omega square V2 sine omega t plus K2 multiplied with V2 sine omega t minus with V1 sine omega t equal to 0. In vibration, amplitude, velocity, and acceleration are expressed as this equation. You can see the equation with x1 and x2. And simplify all the equation like this and go to the metric equal to 0. So let the lambda equal to omega square and the equation for this equal to 0. Since the v not equal to 0, is called characteristic equation, and lambda is eigenvalue and V is eigenvector.
Hi, my name is Shasha. My metric number is Siti 200012. For my part, I'll explain the result and calculation for this group assignment that related to real-world problem. From real-world problem that been stated, consider the vibrating system as shown as figure 1, and our group is trying to find the eigenvalue and eigenvector of the system using 2 degree of freedom and method and power method. The first one is eigenvalue and eigenvector for 2 degree of freedom. From the method assessment, rearrange the equation become matrix A minus lambda, which actually represent omega 2, identity matrix, which is I, multiply with matrix V that equal to 0. Then insert the all values given into the matrix A, and matrix A is become 50, negative 20, negative 20, and 20 minus lambda times 1, 0, 0, 1, then then multiply by V1 and V2 equal to 0. It is equal to 0 because it is a free vibration. Since matrix V cannot be 0, it can be simplified by expand the matrix A minus lambda, which multiply lambda and identity matrix, then multiply by matrix V1 and V2 equal to 0. By use the Craner rules to multiply matrix A itself, which is 50 minus lambda times 20 minus lambda minus negative 20 times negative 20 equal to 0. Then expand the equation to get the value of lambda 1 and lambda 2. To get the lambda 1 and lambda 2, just calculate the value and insert the value using calculator. And the value for lambda 1 is 60, however for lambda 2 is 10. To get an in vibration, we want to find the natural frequency, which is lambda equal to omega square. We want to find the natural frequency, therefore omega 1 is equal to square root lambda, and this is the value, and as you can see, this is the value we obtain, which is lambda 1 is 7.7460, for lambda 2 is 3.1623. Next, use the same matrix to get the value of eigenvector, and to get eigenvector 1, we use lambda 1, and to get eigenvector 2, we use lambda 2. Same method as eigenvalue, which is expand the equation to get the value of V2. Okay. As we can see, to integrate V2, the eigenvector V1 is equal to 1. So the first eigenvector is, which is V2, we get 2.1127. However, for lambda 2, and we got the V2 is 2.3419. Next is eigenvalue and eigenvector using power method. In power method, we try to approximate the highest eigenvalue and its corresponding eigenvector. In power method, we propose two methods of calculation, which is one is calculation of power method itself, and calculate it using a table, which more easier to get the value directly. Okay. Take from the previous question, which is matrix A is 50, negative 20, negative 20, and 20. For this time, it has given initial trial vector and the iteration. The initial trial vector is 1, 0, then and iterated until less than 0.02. By using the table, there are 5 columns that represent K, which is iteration, Vk, the initial prior vector, metric A times Vk, lambda k plus 1, and the last one is error. Okay, by using this table, first put all the non-value, which is the initial prior vector is 1, 0, then matrix A multiply matrix V by using calculator to get the value. As we can see, after get the value, for the value lambda k plus 1 is put the highest absolute value. Next, for the next row iteration to obtain the value, metric A multiplied by metric Vk over lambda plus k is equal to Vk. Then the step is repeated until fifth iteration until it gets less than 0.02. For example, for iteration number 1 is the unknown value. The unknown value is 0, 1, and 0 for Vk. Then insert the value of metric A into the calculator, and metric B is 1 and 0. Then by multiplying metric A and metric B, we get 50 and negative 20. For lambda k plus 1 is the highest value, the highest absolute value. For the next row of iteration, we need to repeat the step, which is metric A, like usual, take from the question. Then metric B, we insert the new value, which is 1 and negative 4 to get the, then multiply metric A and metric B to get the answer of metric A times Vk. Then continue the step until the fifth iteration to get 0.02. Okay, as we can see from validation of MATLAB, the 2DOF and our method has same highest value lambda, which is 60. So we can conclude that the highest value for lambda is 60 for both methods. Thank you. That's all from me.
Assalamualaikum. My name is Siti Nordiana Binti Jamil. My metric number is AD200128. So for my part, I want to talk about part discussion. So based on the results of the calculations, the validation was made by using pre-made software to prove that final result is accurate. The result of eigenvalue, which is lambda, by using 2 degrees of freedom is equal to 60 based on manual calculation, and the value is validated by simulation. By using power method, the manual calculation result of eigenvalue is equal to 60, while simulation pre-made result is 59.9984, which is nearly 60. Since there was a slight difference in power method, the relative error must be determined by applying the formula below. Relative error is equal to absolute measure result minus simulation result, close absolute, divided by open absolute, measure result, close absolute. So the answer or the result is 0.00003. Percentage relative error is equal to 0.00003 multiplied by 100% is equal to 0.003%. Thus, there are 0.003% error in the power method, while in the 2 degree of freedom are accurate since the results are equal for both manual and simulation. Therefore, both methods are suitable to be used in determining the application of eigenvalue and eigenvector.
So here are the last part, which is conclusion. So the conclusion is the eigenvalues and eigenvectors are powerful tools that can be used in many ways in machine learning. The specific set of scalars connected with the system of linear equation is known as eigenvalues. To put it another way, an eigenvalue is a scalar that is utilized to convert an eigenvector. The fundamental formula is Ax is equals to lambda x. The eigenvalue of A is the number of the or scalar value of lambda. When a linear transformation is applied, eigenvectors are non-zero vectors that do not change direction. It only varies by scalar quantity. In a nutshell, if A is a linear transformation from a vector space V and X is a non-zero vector in V, then V is an eigenvector of A if Ax is a scalar multiple of X. A set of all the eigenvectors with the identical eigenvalue jointly with the zero vector makes up an eigenspace of vector x. The zero vector, however, is not an eigenvector. When working with data, it can be used to determine the optimal way to represent the data. For example, if you have a data set with many features, you may want to use the eigenvectors to reduce the dimensionality of the data. This can facilitate work and visualization. Additionally, eigenvectors can be used to calculate the distance between data points. This can be useful when creating models that need to group data points based on the similarity. Finally, eigenvalues can be used as weight in algorithms. By assigning different weights to different features, you can control how much influence each feature. So here are the last part, which is conclusion. So the conclusion is the eigenvalues and eigenvectors are powerful tools that can be used in many ways in machine